Continue to take a look here in sections 5.3 and 5.4, writing linear equations in point slope and standard form. So we're just going to kind of build off of the ideas from the previous video and from the previous lesson. Probably look at a couple of different types of examples that we could potentially be faced with, and then we'll wrap it up. So example 1 here is very similar to things that we did together the other day in class. So it says consider the line that goes through 5, -1 and 4, -5. Write an equation in point slope form. So the first thing you need to identify is point slope form. So that means y minus y1 equals m parentheses x minus x1. Note here that in order to write the equation in point slope form, you need two things. You need a point that lies in the line, and you need to know the slope of your line. Well, they give us 2 points. They give us 4, -5 and 5, -1, so we can use that to find slope. So if I want to find slope here, m equals y2 minus y1 over x2 minus x1. And so that gives me 4 over 1, which is just 4. So my slope is 4. So now my life is real easy because I know m is 4. So there's potentially 2 equations you could write here. You can pick either one of these 2 points, and they would give you equivalent equations. So you could write y minus -5 equals 4 parentheses x minus 4, and this would just be y plus 5. Or you could write y minus -1 equals 4 parentheses x minus 5, and that would really just be y plus 1. So both of those equations represent the same line and would be acceptable here. As far as writing the equation in standard form, remember standard form means get your x's and y's to the same side. So if I take this equation first and I look at it, I have y plus 5 equals 4 parentheses x minus 4. If I distribute first, I get y plus 5 equals 4x minus 16. I need to get this x over here, so I have to subtract it from both sides. And I need to get this 5 to the other side, so I'm going to subtract that as well. And so the first equation I end up with is -4x plus y equals -21. And then over here, if I take this guy and work it down, I get y plus 1 equals 4x minus 20. So I'm going to subtract 4x from both sides. Again, I'm getting my x's to one side, my x's and y's on the same side. So those 1's cancel, those 4x's cancel, so you have -4x plus y. Let me just write this on the final line here. -4x plus y equals -20 minus 1 is -21. And clearly we end up in the same spot. Find the missing coefficient in the equation of the line that passes through the given point. Write the completed equation. So they give you standard form here. Okay, they tell you that it passes through this point. So again, understand that's an x and that's a y that we're giving you. So you have a times 3 plus 4 times -1 equals 5. Solve for a. So 3a minus 4 equals 5. Add your 4 to both sides. So 3a equals 9. And then divide both sides by 3. So a equals 3 here. And so it says write the completed equation. So this guy's really going to be 3x plus 4y equals 5 would be the completed equation. So a little bit different type of problem than what we've seen. But really it's pretty straightforward. Just plug in your x and y and solve. So again, x and y. And so you have the opposite of 2 plus b times -9 equals 4. Okay, so I'm going to add 2 to both sides. Whoops. Add 2. So you get -9b equals 6. Divide both sides by -9. So that says that b equals -2/3. Okay, and so the final equation is -x plus -2/3 y equals 4. Okay, and we'll just leave it like that. It just says solve for b and plug it back in. I'm going to go ahead and let you take a look at part C on your own. No different than what we've been doing. Plug in x and y. So remember, horizontal lines have an equation that looks like y equals some constant c. C could be any number. Okay, and then vertical lines have an equation of x equals a. Again, where a is any constant. Okay, -2, -1, 0, 3.5, 4.5, it doesn't matter. Okay, so vertical lines, x equals, horizontal lines, y equals. So it says write equations for the horizontal and vertical lines through the given point. First of all, let's go ahead and graph our given point, 3, 1. So I go over 3, up 1. So there's my given point, the red dot there. Okay, and so there's exactly one horizontal line, and there's exactly one vertical line that passes through that red point. And your task is write the equation of each of them. Okay, I drew both my graphs on one, so I'm not going to use this graph over here. Okay, now if I look at the horizontal line first, the blue line, remember horizontal line I know is going to have an equation of y equals something, and when I look at the dotted blue line here, every single y coordinate along that line is 1. And by the same argument, when I'm writing the equation of the vertical line, I know it's going to be x equals something. And when I look at the green line going up and down, the x coordinate at every single point is 3. And so you'll notice in these problems, it's pretty straightforward. When it asks you to write the equation for horizontal and vertical lines, you literally just write down x equals 3, all right, and y equals 1. Those are the two lines that pass through that given point. So in part B, again, without doing a whole lot of work here, I can tell you right away the horizontal line is y equals 2, and the vertical line is x equals -1. All right, and again, we could see that pretty easily. If I plot the point, -1, +2, okay, we have a vertical line. Every x coordinate there is -1, and we have a horizontal line. Again, every y coordinate there is +2. And so kind of just a pretty basic idea, but something that you could be potentially faced with. Again, writing equations of lines, that's what we're spending our time on here in Chapter 5. So as always, any issues you have from this particular lesson, have those questions ready to go in class, and we'll be sure to address them first thing.